Hey everybody, so in this video we're going to talk about how to write a quadratic equation if you don't have the vertex and you don't have the x-intercepts. Okay, so for this method we're going to need standard form. So I want to remind you what the standard form looks like. Remember, this is also sometimes called the general form. Okay, so this is the form that we see the most, right? The ax squared plus bx plus c form. Okay, so let's look at an example of what we do when we don't have these 2 points, or these 2 special pieces of information, right? The vertex or the x-intercepts. Okay, so all we have is these 3 random points that the function goes through, right? We don't know if any of these are the vertex. They're probably not. We don't know if any of these, well, we do know if they're an x-intercept because it would be number comma 0, and none of them are the x-intercept, right? So what we need to do is have a different method for coming up with the equation. So we're going to start by plugging each one of these in to the standard form, right, just as x, y. So I have -1 equals a times x squared plus b times x, right? I'm plugging in 1 for x plus c. Okay, so 1 squared is 1, so I'm going to rewrite this equation as a times 1 is a, right? B times 1 is b, and then I have c. This is just equal to -1. Okay, then I'm going to do the same thing with my second equation, x and y. Okay, so I have 5 equals a times 2 squared plus b times x, right, which is 2, plus c. Okay, so 2 squared is 4, so this is going to be 4a plus 2b plus c equals 5. Okay, and then my last one of plugging in x and y, I'm going to get -7 equals a times x squared plus b times x, right, plugging in -1 for x, plus c. Okay, so -1 squared is +1, so this is still just going to be a, this is going to be minus b, and this is going to be c, equals -7. Okay, so what we have now, if you look at these 3 equations, this one, and this one, is something that we actually already talked about in our class, right? I have 3 equations with 3 variables, and I know how to solve this. I need to do Gaussian elimination. Okay, so it's been a while since we talked about Gaussian elimination in our class, so let's go ahead and do this together. So I'm going to copy these equations down into the top of the page right here so that I can make as much space for myself as possible. So remember, when you're doing Gaussian elimination, what you're doing is first you want to pick which variable to eliminate, and you want to do that in the easiest way possible, right? So you're going to be eliminating this variable from your equations. So when I look at this, I can see that for equation 1 and 3, the b is already set up to eliminate, so that's what I'm going to do first. I'm going to eliminate b, okay? So I have my first equation, a plus b plus c equals -1. And then I have my third equation, a minus b plus c equals -7. And I'm just going to add these together, okay? A plus a is going to be 2a. B plus -b is 0. That's what we wanted to have happen. C plus c is 2c, okay? And then -1 plus -7 is -8. Okay. All right. Then I'm going to do the same thing with two other equations. So I'm just going to copy my second equation, which is 4a plus 2b plus c equals 5, okay? And then I'm going to take my last equation and I'm going to multiply it by 2, okay? So I'll have 2a minus 2b plus 2c, and I'm not going to forget to multiply on the right side. -7 times 2 is -14. Okay, so when I add these together, 4a plus 2a is 6a, 2b minus 2b is 0, that's what we had planned, right? And c plus 2c is 3c, and this is going to be equal to 5 plus -14, which is -9. Okay? So now that I have that, I want to do elimination with the two equations that I just made. So 2a plus 2c equals -8, right? And 6a plus 3c equals -9. So I think the easiest way to do that is to multiply the top equation by -3. So this will give me -6a minus 6c equals +24. Okay, and then I'm just going to copy my second equation. So 6a plus 3c equals -9. Now when I add these together, -6a plus 6a is 0, that's what we had planned. -6c plus 3c is -3c equals 24 plus -9, which is 15. Divide both sides by -3, and I get c equals -5. Okay. Once you have one of the variables, you're going into the mode where you're just plugging these numbers in, okay? So I'm going to take this equation right here, and I'm going to plug in my value for c. So 2a plus 2c equals -8, and I'm going to plug in c equals -5. Okay, so I have 2a minus 10 equals -8. So I can add 10 to both sides. -8 plus 10 is 2. Divide both sides by 2, and I get a equals 1. Okay, and then the last thing to plug in is to take one of the three original equations, so I'll just take the top one, this one here, and I'll plug in my values for A and for C. So 1 plus -5 is -4. Add 4 to both sides, and I get B equals 3. Okay? Now, it's easy when you're doing all of this work to lose sight of what the goal was here, okay? So remember, the goal was to write a quadratic equation in standard form, right? Our ax squared plus bx plus c form, okay? So we're going to plug in our value for A, which was 1, our value for B, which was 3, and our value for C, which was -5, okay? Now I can definitely write this without the 1, so this would be x squared plus 3x minus 5. And this is really what we're looking for our final answer, right? We want the quadratic equation, and in this example, it's in standard form. Okay? I hope that makes sense and that refreshes your memory about Gaussian reduction, and I will see you guys in class.